to IntoMath Grade 9 Lesson 2. Today we're talking about polynomials and simplifying algebraic expressions. When we have a combination of numbers and letters in one expression, we call it a monomial. All of them are separated only by multiplication. So, in this case, 2 times x times y times z forms one algebraic expression, which is called a monomial, since there is no addition or subtraction between the variables or the number. This number here is called coefficient, and the letters are called variables, since we can potentially replace them with any number and evaluate this expression based on those values. When we multiply two monomials, we will multiply their coefficients separately. Then we're going to multiply the same bases separately by adding their exponents, and those bases that are not the same are just going to stay separate. So in this case, I will multiply 2 by 3, which is 6, m by m. This is to the exponent of 1, so m to the power of m squared will give me m cubed. I'll add 1 plus 2. And then n and s are two separate variables that cannot be combined. So the simplified expression after multiplying two monomials here is 6m cubed and s. An expression that contains only one set of variables and a coefficient not separated by plus or minus is called a monomial. So 2mn is a monomial. Now, if I have two of these added or subtracted from each other, for example, 2m squared plus 3st, this is now called a binomial because I have two monomials added together. So binomial. If I have three of them, 3m squared plus m minus 1, I could just have a number without a variable, then I call this a trinomial. And anything greater than that, if I keep adding the monomials to each other, I will end up with a polynomial. Poly means many. Now, if we have two terms that have the exact same variables with exact same exponents, but only differ by their coefficients, then those terms are called like terms. If you have 8m squared n and you have 10m squared n, you see that both of the variables are identical with their exponents being the same, but the coefficients are different. So I can either add or subtract these terms, and this is called collecting like terms. So say I'll add them, and the answer will be 18m squared n. Now, if I only change one thing in these two expressions, for example, I will now have 8m n squared and 10m squared n. So see how the exponents are not the same for the same variables? This means these terms are no longer like terms. Sometimes I have two polynomials in brackets and I need to either add them or subtract them. When I'm adding them, it's easy. I just drop the brackets and continue by collecting like terms. But when I'm subtracting two polynomials, I need to be really careful, since this subtraction sign, the negative, affects every single term inside the brackets. It does not affect the first bracket, it does affect the second one. So this expression will remain the same, but this one will have all the signs of every single term change to the opposite. So I'll get negative 3m squared minus n. Now I'm looking for the like terms. Like terms in this case are 2m squared and negative 3m squared. Remember that the sign goes with the term. Then another one is negative n and negative n, and then I still have 3. So I will combine like terms together by adding their coefficients and keeping the variables the same, not changing the exponents. So 2 and negative 3 gives me negative 1 m squared remains as is. Negative 1n and negative 1n is negative 2n, and then plus 3 does not change. Since we usually are not writing 1 as a coefficient, we can rewrite it as negative m squared minus 2n plus 3. And this is our simplest expression from the original difference of two polynomials. This is it for lesson 2. I hope you learned something new, and I encourage you to do some practice now. And I'll see you in grade 9, lesson 3.